Okay, in reflection, light is reflected from a mirrored surface or a silver surface, or even just a shiny surface. And when light is reflected, it always follows this rule. You have a normal line, which is this dotted line down here, and that is perpendicularly drawn to the surface that the light is shining on. This is your incident ray coming in towards this shiny surface, and then this angle here, it's always the angle between the ray and the normal that we measure. That is known as the angle of incidence and is given an I. Now, if I can draw this properly, what will happen is, from the law of reflection, those rays will always reflect at an angle R, where I is always equal to R. So the angle between the ray and the normal both should be the same. If you're drawing this in an exam situation, you need to make sure that the rays have arrows on and that they are roughly equal, unless they tell you that you have to measure the angles. Generally, they tend to measure it by I. So what happens when you get a wavy surface? Well, people think that the light will reflect off in all directions. But in actual fact, that's not the case. It's just that the normals are actually facing in all directions. So if we take this little bit of surface here, my normal would be out here. So any ray coming in like this would actually reflect out like that, where these two angles are equal. So that is what we call diffuse scattering. So it is still a form of reflection, and it is why we can see things like your desks and stuff like that, even though you can't see an image inside of those. So the other thing that we need to talk about is diffraction as well. So diffraction is actually a property of waves where when they go through a gap, the wave approaching like this will actually diffract and come out and spread out as the wave passes through a gap. Now, there are conditions for the gap. So the smaller the gap, generally, means that you spread out more. So the waves will spread out a lot more when you have a smaller gap. However, there's a limit to the smallest gap you can have. The gap has to be approximately the same size as the wavelength. Now, on a diagram like this, the wavelength is represented by the distance between these two lines there. Those are the wavelength, that's the wavelength. When you get a much larger gap, what will happen is it will spread out, but it won't spread out very much at all. So you will get this kind of, it's slightly more directional, but it will spread out slightly.